So Miroslava Munguia Ramos is the Woolsey Fire project recovery lead for the Santa Monica Mountains Fund. And her presentation this evening will highlight wildlife recovery after the Woolsey Fire. So you're on. Unmute yourself.
Great. Thank you, Snowdy. And thank you everyone for joining me on this fun, hopefully fun evening for the next, for the next hour or so. Like Snowdy mentioned, my name is Miroslava Munguia Ramos. I work with the Santa Monica Mountains Fund, which is the official nonprofit partner of the Santa Monica Mountains National Recreation Area. So I get to wear several hats in that my funding comes from the Park Service, but I am not a federal employee. So I get to joke that I get to wear colors instead of constantly wearing a green and gray around the office. And today I have the great pleasure to showcasing some of the research images we've collected from this project that's now going on 5-6 years now in the making. So like Snowdy mentioned, I'm gonna go through the presentation, but I encourage you all write your comments, questions in the chat. I value engagement, so it's not like me just talking into a void. So if you have questions, comments, concerns, or clarifications, by all means, go ahead and add them in the chat, and I'll make sure to address as many of those messages at the end of the presentation. So I do want to acknowledge that the Santa Monica Mountains National Recreation Area includes the ancestral lands of the Chumash and Tongva people. The National Park Service, as well as the Santa Monica Mountains Fund, thank them for their past, present, and future land stewardship. And we're grateful for the ongoing tribal relations we have with them. And I always like giving a plug for our Setwiwa Native American Indian Culture Center, which is based out of our park property in Newberry Park. So this visitor center is open Saturdays and Sundays, 9 a.m. to 4 p.m. We have lovely rangers there who are happy to talk to you more about our Indigenous partnerships across divisions in the park. And we do host a monthly Indigenous guest host program where funding through the National Park Service as well as the Santa Monica Mountains Fund will actually hire out an Indigenous host to talk about some form of their craft. And I want to highlight that we don't just bring out Chumash and Tongva elders. We have folks from all over, and we invite them who are willing to drive out. And our next workshop, I believe, is going to be this month, where we're going to have Michael Williams chatting a bit more on making dream catchers. And I'll include the links to sign up and look into all of these workshops at the end of the presentation. So as we're going through, I have the great fortune to be the single person chatting with everybody today. But for a project this big, I want to always start off with the acknowledgements. It takes a team of people, organizations, federal, state, local agencies, volunteers, private landowners who really make this really collaborative and, in my humble opinion, a very successful project. So this is a huge list of just a small portion of people who helped put this together, but I always like highlighting that it is a group effort. I'm the one chatting with you, but I am by no means the only person who has been putting in the work towards this project. And as a quick outline of what we're going to be going through today, we'll touch a bit about the ecological significance of the Santa Monica Mountains, which I'll constantly refer to as SAMO for short. We'll talk about the wildfire history of the area, touch a bit on the Woolsey Fire and its impacts, talk about the Woolsey Fire Recovery, or WFR, project goals and objectives, talk a little bit more about cameras, some stories in the field, some preliminary data we're just getting out of everything, some upcoming programming if you'd like to learn more about the project, and some take-home messages. So for my CNPS local chapter, a lot of this might be review, a lot of it might just be rephrasing altogether. Bear with me as we touch base on the significance as to why we're extra special here in Southern California. So the world, 7 continents, tons of different ecosystems, and each one has a very unique aspect to it, whether it be that it has rain year-round or snow year-round. There's different types of biodiversity all across the world, whether you're in high altitude, whether you're in the ocean, whether you're along the coast, whether you're inland. There's a lot of different impacts and different aspects that impact the amount of biodiversity that's in a given area. For conservation efforts, across the world, we have areas known as biodiversity hotspots. And these are areas that have a significant concentrated amount of unique species, whether they be plants, whether they be bacteria, whether they be mammals, birds. A concentration of a lot of different species in one area makes it biodiverse, but it's considered a hotspot because a significant portion of the lands that these species are in have been impacted or altered in some way, shape, or capacity. So on the slide you have here, we have about 30 plus biodiversity hotspots found all over the world. And it's always fun to highlight that we are there we go. The California floristic province is one of the real important ones here. And that we in California, aside from having sunny days for a good chunk of the year and tourists year round, we also have one of the most unique areas when it comes to biodiversity, more specifically, the flora we have in the area. Now, we go even further focusing in on California. We're one of only 5 areas in the world that have this unique Mediterranean ecosystem. What this means is that we have long, dry summers and short, wet winters. It also means that our plants and animals and other living critters in the area have it highly adapted to this very unique biome that is only shared with us, central Chile, the southern tip of the continent of Africa, Southwest Australia, and of course the Mediterranean basin, where we've earned our name. So huge continents, huge countries, huge land masses, but a very, very small percentage of all of that has this unique Mediterranean biome. And within each biome, we have a very specialized specialized biodiversity to it, including bacteria, insects, plants, any living critter. It's unique in some capacity here in the very specialized Mediterranean ecosystem. And it's clear to see as you're hiking and recreating in the Santa Monica Mountains. Now here, we're one of 400 plus national park sites across the US, and we're even more unique in that we're not just managed by one agency. Whereas a lot of park sites are purely federal, meaning all of the property, everything is managed by the federal government. We're managed by the federal government, the National Park Service, which you'll see in these areas, which are a slightly darker shade of green, such as Zuma and Tracus Canyon, Circle X Ranch, Paramount Ranch, Peter Strauss Ranch. We also coordinate this land management with our state agencies, including the California State Park System, as well as the Mountains Recreation and Conservation Authority, or also known as MRCA. They help manage properties including Malibu Creek State Park, Topanga State Park, Point Mugu State Park, Corral Canyon. So it's, again, this really big collaboration when it comes to conservation of our very unique Mediterranean ecosystem in the California Floristic Province. And of 400 plus national park sites, there's multiple agencies managing the property. So unique on unique on unique on unique. We're not special enough just looking at maps. As you're recreating in the mountains, you can see this very distinctly across the ecosystems that you're going out and about. Whether you're looking more towards Zuma Canyon, where you're starting along that nice marine layer, it's getting warm in the day, you're working right up towards the canyon, you can feel that sea breeze cooling you off as you're huffing and puffing up into the higher vegetation and the much more exposed sunlight. You're also going to see that change in vegetation, that change in biota, in life altogether, from seeing woolly blue curls in bloom to smelling that chaparral classic coyote bush, as well as our cowboy's cologne. We're going to see and smell and experience a lot of differences just across the mountains and across the trails you go about. And then depending on what your specific niche is and what you most aspire to see when you're on the trails, you might be looking out for some of the most colorful species, like our Humboldt leopard lily on the top left here. You might be looking at specific flowers and looking at the pollinators, like I forget the specific species of the butterfly in the center there. Or you can be looking for more scalier friends, like our rattlesnake on the top right there. Maybe you just hear some rustling, and as soon as you turn around, you see a mule deer staring you down because you're interrupting its lunch. Or you'll hear the call of one of our kingbirds on that bottom middle image munching away in some of the insects. Or you're really brave, you're really bold, you join a ranger in a night guide program. Using UV light, you can see the bioluminescent scorpions glow under these adapted flashlights here. So across the park, across the trails, across the canyons, across the time of day, there's going to be a lot of variety on what you see, whether it be plants across the season, whether it be the activity levels of our lizards, scalies, reptilian friends, whether or not there's sunshine, or just hearing movement out and about throughout the day. So there's a lot of movement, a lot of change. And this is just a small selection of photos I've seen. I'm sure everyone has dozens of more stories, and I'd love to read more about them. So feel free to drop them in the chat, talking about some of the most unique experiences you've had with the species, or just going out and recreating something that really stands out to you in the mountains. Now, just as all of these species, all of these plants, all of these animals are a natural part of this vegetation, of this ecosystem, we have to acknowledge that in this chaparral environment, wildfires are a natural part of the Santa Monica Mountains. And a significant portion of the Santa Monica Mountains, when we're looking primarily at vegetation types, is looking at this chaparral or this shrubland plant community. And it's important to know, and it's very easily misconstrued. I see it on social media a lot. I have to, practice taking deep breaths and finding best approaches to kind of guiding folks in the right direction. That in these chaparral ecosystems, our vegetation is really sturdy, really strong. Again, they've got to survive long summers without a drop of rain. And then they have to make the most out of these short, wet winters when those storms come on in and make the most of it. Now, these plants, they're sturdy, but that also means they're just fire adapted, not fire dependent. And a lot of times we have folks who come by and they're like, yeah, but there's plants like the sequoia and the redwoods that need fire. That's true. Our chaparral vegetation is not one of those plants, or it's not one of those plant systems, ecosystems, where our plants, they'll do okay with the fire. It'll come in, it'll burn the top roots or the top crown of the plant, and the roots will be a-okay. But this vegetation is not one that is reliant and looking forward to fires. We do have some flowering species across the park, including fire poppies, that are waiting to germinate once those fires come in, but it's not the primary vegetation type across the Santa Monica Mountains. Now, if we were to look at a map, which I'll show in the next slide, that looks at the current fire return interval, or the average of how often a fire comes in a given area, on average, we're looking at seeing a large-scale fire in the Santa Monica Mountains about once every 28 years now, where historically our scientists estimate that fire return interval is probably, before a lot of human interaction and intervention, probably more towards 70 or 100 years, seeing this large scale fire impacting the Santa Monica Mountains. So 28 is definitely a significant change on average versus that 70 to 100 years. So we're already seeing that plants are starting, these vegetation types are starting to see and experience an increase of fire frequency in an area. And even just looking back at historical records, from the time that the National Recreation Area was established in 1978, we have records that also go back around 1925, when LA County, and I believe it's primarily LA County for this study, was keeping track of the major wildfires that impacted the area. We have some park sites that have burned as often as 13 times since 1925, and other sites that haven't burned since. So when we say on average, the park is expecting or is receiving a fire about 28 years or so, take it with a grain of salt, just because an average isn't equally impacting every park area. And in addition to seeing how these shorter fire intervals are taken with a little grain of salt, we also want to keep in mind that the vegetation, the topology, how steep or how rigorous the terrain is going to impact how a fire kind of spreads around. So the numbers are kind of a guideline, but we actually need to do assessments out into the field to really get a better feel of how these numbers give us the story altogether. Now, when we're looking at that significantly shorter fire interval, or we're seeing that these fires are impacting the Santa Monica Mountains at a higher frequency than expected, this is where we get a little bit concerned because we know that wildfires are a natural part of our ecosystem, but it's the frequency that's got us a little concerned. We're not really sure what's happening. And one of the big concerns that we have is that with these native shrubland ecosystems, they're adapted to fires. They're not expecting that many. And if fires are coming significantly more often than expected, there's not going to be a significant enough period of time for these plants to catch their breath, regenerate, grow, and be ready for the next fire. And if there's not enough time between these fire events, let's say fire A comes 2010 and fire B comes 2011, that 1 year might not be enough for some plants, and entire areas can actually go what's known as a type conversion, where the vegetation altogether will shift and change, and you're going to be losing a specific type of ecosystem. For example, for our shrublands that have undergone significant fires in a really short period of time, we're seeing fewer and fewer shrubs and more non-native and invasive grasses taking over and outcompeting the shrubs that take a while to establish their roots, get nice and sturdy, and support a shrubland versus a grassland ecosystem. And of course, especially in the past 10 years or so, plus or minus the very wet winters we've had in the past few years, as we see these temperatures increase and drought increase, the live fuel moisture, in this case, really dry vegetation, will be at critical levels, meaning we basically have more kindling unintentionally in the park earlier in the year and for longer periods of time, which could potentially extend the length of our fire season. And with our fire crew in the park, we've come to know it as less so a fire season and more so a fire year. And that there's just so much vegetation that has unfortunately gone under drought and has gone really dry that we're pretty much always on fire watch. There are, of course, peak conditions such as the Santa Ana wind events in the fall, but for the most part, we're just always alert that vegetation will take a good amount of time. And while these wet seasons have helped us, we want to constantly just practice being safe and being aware of these situations. So I'm going to show some of the maps that kind of hopefully help demonstrate this. Don't sweat it too much. It's a little hard to read off of the screen versus on a blown up diagram. But with this first diagram here, we're looking at the fire frequency and the average fire return interval between 1925, which is when fires were first when folks started taking notes of the first fires, up to 2023. And here you'll have beautiful color gradients where the pale and the blue colors show that a fire has only passed the area between 0 and 1 times on average, whereas those darker areas, the reds, the burgundies, and almost the browns, have burned over about between 9 and 13 times in the past 12 to 10 to 12 years. So areas, for example, here on the east side of the park, so we're looking at Topanga State Park, Temescal Canyon. Again, this is up to 2023, so we're not including the most recent fires, have only burned about once in almost 50 years. Whereas areas, if we're looking up north around the Simi Hills, have burned between 5 and 8 times between the past 16 and 12 years. So this map is just to show that there is a variation. Not all areas burn at the same time at the significant rate. So there is that change. So the average doesn't include again, take the average number with a grain of salt, but this is just showing you that some areas burn more often than others. This next map, just showing you that, there are different fires at different rates. And this next map between 1978, which is when the National Recreation Area was established, and 2017 shows you the map of where wildfire ignitions were reported in the Santa Monica Mountains. Now, it's important to highlight here that I don't want you focusing on counting every single point, but I want to showcase the kind of the color gradient and the color change. So the little points are going to vary. The lighter points are showing further back in time from 1978, and the darker red points are the most recent, so from 2010 to 2017. I don't want you to focus exactly on where and where all these points started. But I want to show that if you look at it overall, you're going to see more of these reddish burgundy points, meaning we've been able to record more wildfire ignitions from 2010 onwards versus what we've had previously. So, and most of these are unfortunately human caused, not intentionally. Accidents do happen. For example, the several fires were started just off of the 101 freeway from cars backfiring, not out of malice or poor intention. It's just such an urbanized park. In fact, we're the largest urban national park in the US. There's a lot of we're in that urban wild interface. There's going to be a lot of human interaction. And this is where, with the help of federal, state, nonprofit partners, we're able to mitigate those risks so that folks can safely recreate in these parks without constantly being on edge. But we do want to acknowledge that, especially when it comes to wildfire ignitions, a lot of it, to some capacity, may have been from human interference altogether. So looking at this, looking at the past can kind of brings us back over to the Woolsey Fire. So this began November 8th at 2018. So it's been 6+ years now since the fire ignited at around 2:30 p.m. And it began in the Santa Susana Field Laboratory over in the Simi Hills. And after rigorous investigation, it was confirmed that the fire began from sparks from the Southern California Edison power lines near the Chatsworth substation. And this fire was one of those where it was just unfortunately the perfect storm of events. All it took was a small spark in the middle of what would have been, I think at the time, was one of the worst decades of drought we've had in California. Not to mention the Santa Ana winds were picking up right in that fall season. So all it took was a spark with dry vegetation or live fuel, like we mentioned earlier, and that wind came in and the fire just took off running. It crossed the 101 freeway early in November, and within 24 hours, so just about a day, over 72,000 acres burned. So this was a significant fire. And we've had folks, they don't mention it aggressively by any means. They just mention it a lot that, oh, your website, your park, you mentioned the Woolsey Fire a lot. Well, what about all the other fires? There are a lot of fires, but the Woolsey Fire by far was the largest. And by the time, just by pure acreage, so over 290,000 people were evacuated, over 1,600 structures were destroyed, and over 300 were impacted in some capacity. And by far, our firefighting teams, in collaboration with CAL FIRE and other partner agencies, made it clear that the priority was to save lives, and then, if possible, property, and then, if possible, resources. And I know when it comes to fire management, it can be a little bit of a touchy, controversial topic. So I do want to preface that for this topic or this presentation, I'm only going to be focusing on the ecological aspects of the Woolsey Fire. But based off of what our park personnel has mentioned, they made it clear that firefighting priorities were lives, then property, then resources. The fire began November 8th and was 100% contained November 22nd of that same year. And here I want to go over just the span of the fire. So here's a map, a similar map from what we saw earlier, where it shows you based off of the color when the most recent fire impacted an area. And prior to 2018, the largest fire was known as the Green Meadows Fire, which impacted the western part of the Santa Monica Mountains. And it impacted about 38,000 acres or so in 1993. And then almost tied for second were the Springs Fire of 2013, which burned just about 23,500 acres, again, on that western side of the park. And then the Topanga Fire of 2005 burned just about 23,000 acres as well. And again, highlighting that just because one area was burned doesn't mean that the next area is likely to burn just by pure chance. Nature is nature. We can do as many calculations as we like and estimations, but nature will be nature. There's only so much we can impact there. And I don't necessarily want you to focus on the numbers, but I want you to just kind of take a moment, look at the map, get a range and the size of at the time, the three largest fires we had in our National Park Service history for the Santa Monica Mountains. So to give it another, 10 moments. And then here is an updated map. So let me go back one more time. Here you have the Green Meadows Fire and the Springs Fire of the western part of the Santa Monica Mountains, and the Topanga Fire on the northern end of the Santa Monica Mountains. And combined, the three largest fires then were still just under the footprint size of the Woolsey Fire of 2018, which burned almost 97,000 acres of the Santa Monica Mountains and nearby mountain ranges. Over 65% of the natural areas in Simi Hills were impacted. And if you're looking at the Santa Monica Mountains National Recreation Area, which you can kind of tell on this dashed line, and I'll show a clearer image on the next slide, about 42% of the natural areas burned in the Santa Monica Mountains proper. Now, if you go into finer detail, whether state parks versus federal property, which one had higher percentages of areas impacted by the fire, it was between like 80% and 90%. It's really minute differences between the two, discrepancies. But for this presentation, I'm focusing less on who was hit the hardest, and instead focusing more on just the overall scale, especially when it comes to wildlife. Because I've yet to see a study where wildlife are prioritizing going on state property versus national property necessarily. And instead, we're looking at how that connectivity of all these wild areas were impacted by again, the largest fire in our park's history of 2018 was the Woolsey Fire at just under 97,000 acres. And of course, with a fire of this scale, our researchers weren't sure what to expect next. You have studies looking at all across the world, forest fires, fires from different national park sites to see what happens next, what's going on. But in a highly biodiverse area, in a highly urbanized national park, in a park managed by multiple agencies, for most parts, it's really great being so unique, but in this case, really difficult because not many other parks have the exact same criteria as ours. So it's really hard to compare and say, okay, what do we expect? What's next? What's going on? And that's where, and then here's the clearer map of the Woolsey Fire footprint. So for those who are familiar hiking in the area, the fire impacted the Upper Las Virgenes Preserve, Chesborough and Palo Quemado Canyons, a significant portion of the park, and pretty much the only areas that weren't impacted by the Woolsey Fire were the western corners of Point Mugu and the eastern sections of the park, including Fryman Canyon, Franklin Canyon, Topanga State Park, and King Gillette Ranch. But again, we're at this point where our researchers, our park staff weren't really sure, because of how unique our park is, what to expect, what's going on. We can't really compare notes with other parks across the world, really, to see how specialized our park is compared to others. So that's where we're looking at impacts altogether. So we took note of the infrastructure damages that were recorded. So this includes what was western town of Paramount Ranch is unfortunately no more, but being rebuilt, and hopefully the next year or so will be open to the public. Peter Strauss Ranch, the foundation is the only remnants that remain. The Rocky Oaks Ranger House, as well as the Cultural Museum, was entirely gone in the Woolsey Fire. And the Rocky Oaks Cultural Museum, that really stung because that had just been completed that year. So we had just moved all our archival specimen, and they were pretty much all gone after the Woolsey Fire. There were Sakeet Ranger residents, a significant portion of the UCLA Lake Kretz Field Station, and of course there was significant damage to the recreation trails all across the park. And this is a photo taken from a trail cam, not from this project, but you can see how the fire just kind of took off with the existing vegetation. And there's a camera right in the center here. And this was just a lucky photo. We had no idea the fire was going to be going there. We just had a camera at the right place at the right time. And of course, the camera was entirely melted, but we were able to salvage the SD card to pull the images off there. And then for showing some of these ecosystem impacts, this is from our vegetation inventory and monitoring team in our park, where they go out and they assess what species, the amount of coverage that a specific species encapsulates in a given area. So the image on the left, you can see it's dense with vegetation. You see some laurel sumac in there with a PVC pipe as a marker as to where our veg team is able to go out and about. And on the right was right after the Woolsey Fire. So entirely barren, almost a moonscape. And park staff who worked there, worked before and after the fire, I've heard their stories, and a lot of them mentioned it was just empty. You wouldn't hear birds, wouldn't hear as many animals kind of scrambling around. You wouldn't hear rustling around. It was just entirely barren. So the fire definitely had a significant impact. And we see these on firsthand. So we know right after the fire, yes, vegetation was impacted, but again, we're not able to compare and contrast. We're not able to see, what the site's going to look like in a few months. And it's hard to compare with other parks that aren't as unique as ours. So that's where we really wanted to focus in on the existing data and studies we had. So we were looking at for starters, the collared animals we have. And in our park, our wildlife team currently collars 6 different species, including mountain lions, deer, foxes, coyote, and bobcat. And when we're looking at the data of animals that have these GPS collars, so they'll send a location a few times a day just so we can see what they're up to and where. Of the 11 mountain lions that we had collared in the area, we know for a fact that 2 succumbed to the fire. P64 was known as the culvert cat, and I'll go into more detail about him in a little bit, survived the fire, but he had some damage when his body was assessed, what we believe he was impacted by the fires. And then P79, or the 79th puma, or mountain lion of the study, was believed to be killed by the fire. His GPS collar sent out a mortality signal saying that the animal is no more, but researchers were unable to track either the collar or the body, and we believe it was probably just had basically disintegrated after the fire. Of the 4 collared bobcats we had in the fire area, 4 of them had shifted their home ranges, and B362, or the 362nd bobcat in the study, actually had a den in a home in Simi Hills, which I'll talk about in just a few moments as well. And I always have to highlight our restoration team. So this is a collaborative effort with the National Park Service and, again, the Santa Monica Mountains Fund. They have planted over 150,000 native plants since the Woolsey Fire in areas or in the fire footprints of the Springs and the Woolsey Fire. So this includes areas of Rancho Sierra Vista. This includes Chesborough Canyon. This includes Zuma Canyon. And if you're looking again at a summary of the over 150,000 plants planted to date, about 60% of the shrubs and herbs have survived. And then of the trees, including oaks, including willows and black walnut, about 55 to 85% of them have survived, depending on the area. And I'll talk more about ways to get involved with the restoration team closer to the end of the presentation, but again, it always seems doom and gloom and just being like, it's sad and barren, but our teams are doing an incredible job with the help of the Park Service, with the help of Samo Fund, with the help of our park partners and volunteers to go out and about, which I will touch to that closer to the end of the presentation. When we're looking at, again, specific critters, individuals we saw impacted by the Woolsey Fire, we're looking at those collared animals just because we were able to see where they're going. And P64 was a pretty unique mountain lion. He's known as the culvert cat because he was able to make 42 successful freeway crossings across the US 101 and 118 freeway. So not only was he just able to get lucky and use these culverts, or kind of like these little tunnels, to go back and forth on the freeway, but he was able to use it so comfortably. He did it 42 times and survived each time. So he was like our little shining hope, like our bite-sized P22 here in the local to the Santa Monica Mountains. And I want to highlight this map here, which is, again, very busy, but we'll walk through it together to see how his activity had changed during the fire. So Here you can see this black line shows you where this mountain lion was moving and grooving. And mountain lions are large, they're territorial. And as P64, as an adult male, he traveled a lot of land to be, basically mark his spot and say, this is my territory, and make sure and discourage other male mountain lions from being nearby. So if you can follow my cursor here, I'm just going down on this black line. You can see he traveled a good distance of time just hanging out, doing his lion things, checking the mail, going for a walk, going to the grocery store. And right around here, you'll see the points have now shifted to this red. This is where P64 was the day and the hour the Woolsey Fire ignited. So you can see here on the top right of the map, this is where that ignition point began, and it worked its way down towards the 101 freeway south. So this red line here shows you the fire perimeter of where the Woolsey Fire hit. And if we follow the path of P64, we can see, again, these green points have now shifted to red. So we're now watching P64 move around as the Woolsey Fire is active. So he's working his way further east. He's working his way south. So this is already at 10 p.m., about 8 hours after the fire ignited. And keep in mind that fire crossed the 101 within a day. So the freeway or the fire is working its way south. And we see right at midnight, he's right on the edge of the fire perimeter, right along some neighborhoods. And then he bounces back almost towards where the fire ignited. And a few days after the fire, so ignited, so November 10th, we see he worked his way further north. And then this is where we see a collection of points where he wasn't moving. And this is what's known as a mortality signal, meaning no movement, no activity. The caller sends a signal out to the GPS satellites that work its way back to our biologist's computer and say this animal has most likely deceased. And again, this is, we believe, we unfortunately have yet to find a way to communicate with animals to this extent. We believe that right around midnight, P64, an animal who's been comfortable going back and forth on freeways, who might have been used to at least going under cars, might have got freaked out by the increased firefighting activity, the lights, the siren, the noise, the evacuation orders, people going out and about, that instead of putting himself in a people-heavy situation, he worked his way back to stay into areas that had very little human interference. So our researchers recently released a paper, I think in the past year or so, if I'm not mistaken, where mountain lions have actually had increased risky behavior in these impacted fire areas to avoid people more so than they would avoid fire. So when it was safe to do so, our researchers went out to where these collected points were, where the mortality signal was sent out. And this is where researchers found the body of P64 with burnt paws, and he was entirely emaciated or starved. So it's believed, again, it's really hard to say with certainty unless we were there. It's believed that P64 had burnt his paws in the fire and was unable to go and feed himself after being impacted by the fire. He may have just starved to death at that point. So unfortunately, not a happy story, but having these collars, this long-term monitoring helps us get a bigger picture of these larger impacts. On a much brighter note, with our bobcats in the area, like I noted, 4 of them shifted their home ranges as a result of the Woolsey Fire. So the map on the right shows a very similar diagram where this red perimeter, this kind of blob that opens and closes and opens and closes, shows you where the Woolsey Fire impacted. And it's here in the area, it's burnt these natural areas around these neighborhoods. And what's unique is that there are some patches, especially in the center where you see these very colorful blue and pink and red GPS points, is that there are these altered open spaces. So think of a golf course where it's green, it's open, but you can tell the grass is not always going to stay green. It still has some of that human ongoing maintenance. Our researchers actually collared B362 right on this left spot right here, less than a day before the Woolsey Fire ignited. And we noted that B362, she's been hanging around doing her thing, staying in these pockets of greenery where the nearby areas had been impacted. And researchers noted right around denning season that she was really loving like one specific backyard. And bobcats are still cats, they're not crazy around people. So once it was safe to do so, and our researchers got permission from the private landowners, we were able to go in, and this was the first time in Santa Monica Mountains bobcat history. We have one of the longest bobcat studies at over 3 decades now of collaring and monitoring bobcats. This was the first time we recorded a bobcat kitten den in the backyard of someone's home. And our researchers make a joke that this is the only time our work is ever going to be highlighted on People magazine saying, oh, new kittens found just hanging out in someone's backyard. And it kind of gives you, in my mind, gives you hope because animals are able to adapt. They are able to acclimate to these changes. And while with our bobcats, they're not looking for backyards to have their homes in or have their kittens, it's one of those things where we are seeing animals are adapting to the best of their ability. Whereas P64 was already kind of going back and forth, and we might not have been sure what would have happened if, if we play the what if game. But we could see with B362, with these changes, she was able to adapt and have her little ones in someone's backyard. So again, this long-term monitoring, this maintenance of seeing what's going on can really give you a fuller, bigger picture of the impacts of major environmental impacts, including wildfires. And that's where the Woolsey Fire Recovery Project came to be. So the initial study design was developed about 5 to 6 months after the fire was completely contained by park biologists as well as UCLA master student Chloe Nuzil, who's now doing her PhD in mountain lion studies, which is always very exciting to see folks bounce around from universities to projects. And this project was really ambitious because biggest fire in the largest urban park in the US with a lot of different species and a lot of ongoing data collected by our vegetation teams, our wildlife teams, our cultural resources team. It's a big ask to say, what's next? What is going to be changing? And again, this huge area. So we decided tried narrowing down our questions to 4 main goals. So we wanted to focus on monitoring the recovery of natural systems, including wildlife communities, after the fire. We want to understand the impact of future fires by providing pre-fire data. So by continuously having this long-term monitoring, just similar to with P64 and B362, we had no idea the fire was going to come, but by having those animals collared, we can already see kind of a before and after. A similar concept is going to be applied to this project. We're able to see, okay, we know a wildfire is going to be here. Let's at least have continue monitoring. So when a fire does come, we have that explicit before and after its arrival. We want to provide valuable information about wildlife communities across the park. So far, this project has contributed data to about half a dozen other graduate students who are collecting information about quail, who are collecting information about rare species. For example, 2 weeks ago, it was the first time we captured pictures of a ringtail, which is a species we have no idea about really in the park, just because we were in the right place at the right time. So that long-term monitoring, while we have specific goals for this project, it fortunately leaches into other projects, including monitoring wildlife communities of Samo and the Simi Hills before and after this little thing known as the Wallace-Annenberg Wildlife Crossing. So it's all very interconnected, interdisciplinary. This overarching, ambitious project is not just going to provide information for one project, but to a series of projects across the park and agencies and our partner organizations. So this is going into the nitty-gritty, just to kind of give you a big overview of this project. It started off as having 180 randomly selected sites in grassland, shrubland, and riparian or river and or water ecosystems. And it lines up nicely with the existing sites that the vegetation inventory and monitoring team are looking at. So for a lot of these sites that we have information about wildlife, we have information about the vegetation there as well. the cameras and the vegetation team, they work on a different schedule. So we're not going to have as nice of an overlap. So we're not going to say at this day we have animals here, and at that same day we have a toy on in the middle of the site. So there's an overlap, but not specifically of set dates. And we have 60 wildlife cameras rotated across these sites. And the sites are distributed across the Santa Monica Mountains, the Simi Hills, as well as the Santa Susana Mountains, which were all impacted to some capacity by the Woolsey Fire. About 3/4 of the sites are in areas that were impacted or were burned, and about 1/4 of the sites were not impacted. So they're kind of our control to see, okay, this site hasn't burned. Let's see what happens in comparison to the others that did. And the cameras are rotated several times a year between sites by volunteers and technicians. So you're not going to have one camera across all 180 sites. Instead, they're on a rotating basis, just so we can get a fuller picture of what's going on all across the area. And the image on the left is just showing you the points as to where they are and how they're pretty evenly spread out, depending on where we have access, jurisdiction, and where it's feasible to place a camera. Now, when we're looking at a camera, it's known as a wildlife camera trap, a game camera, a trail camera. It's got a lot of different nicknames to it. The important parts to look at is that they have an infrared array. So it's this grid on the top that allows us to take photos without using flash at night, so we don't disturb the wildlife. We have a light meter, which will help the camera determine, okay, infrared, not infrared, daytime, not daytime. We have the lens in the center, which takes the photo. And we have a passive infrared motion detector, which is basically a beam where if anything triggers that beam, it'll take a photo right away. And it looks from just an image, it looks very intimidating, but up close, it's kind of cute. It's about the size of my hand, pretty compact, very robust. We use the Reconyx Hyperfire 2 model, has a series of batteries, and I've had cameras deployed for 9 months at a time, still taking photos. I've had cameras that after 2 weeks will fill up its SD card. So it really varies on the site and the terrain. Pretty useful and gets you a lot of very valuable data, which I'll talk about in just a second. It's important to note that we place these cameras with permits and permission granted explicitly for research purposes across the park. And I preface it not because I think it will happen, but because I've gotten questions in the past about it. In National Park Service property in the Santa Monica Mountains, these cameras are restricted primarily to researchers who reach out to us to get a permit. If you are so inclined to place a trail camera on your own personal private property, feel free to do so, but please don't get any ideas. We found some cameras out and about in the park, and it's well-intentioned, but can impact wildlife if not placed properly. We've placed them intentionally off trail on these covert posts that'll capture wildlife behavior without impacting it. So if you see the image on the left, you got to squint really hard, but you'll see a metal post with the camera attached to it, just blending in pretty nicely with some sage in the background. So I'm circling with my cursor because the whole point is that we want animals to just live their life. We're not trying to attract them. We're not trying to lure them. We just want to capture what's already there. We're not trying to influence their behavior by any mean. We'll clear nearby vegetation just to make sure we get a clear view of the animal. If we don't clear it, what'll end up happening is, like I mentioned earlier, you'll have a camera fill up within 2 weeks because you'll have images like the one on the left where you have part of an animal ear, but who's to say what animal? It's so difficult to see in this little left corner. And then for more of the nitty-gritty, we process these photos using this AI mega detector. So it'll sort images as blank, animal, person, or vehicle. And for context, the most recent images we had processed, we had about 1.5 million images over about a year and a half. And of those, about 16% of them were labeled animal. Then I'll talk more about it later. Species of animals are labeled with volunteer support through this website called Zooniverse, but we'll get to that in a little bit. So if we don't clear the vegetation, we'll be lucky if we get a little corner of an animal's ear, tail, body part triggering the camera. But more often than not, you get a bunch of grass, which that's nice. One photo is really cool. Imagine 3,000 photos of the same pieces of grass dancing back and forth. It's very soothing, it's very calming. But 3,000 photos of the same piece of grass means you're not catching those critical images of a mountain lion or a kangaroo rat or a wood rat or some birds going through in the same area. So it looks nice, but it's for this project, it's not the intent. So we have to strategically clear the vegetation as it's in the front lens of the camera. And then when you're really lucky, you get that Nat Geo, that $5+ shot where you see vegetation and the wildlife and how it interacts with it. Like I mentioned, in the most recent batch of photos, 1.5 million photos had maybe 200,000 images labeled as animal. And of those maybe 200,000 images, you're lucky if you get maybe like 100 really crisp, clear, shiny, easy to identify photo, like National Geographic quality type images, like this young buck here with still having some velvet on his antlers with some penstemon. I think that's chaparral bush mallow in the back, just kind of creeping towards the camera. So you'll be lucky to catch those images. And then, this is where I'll talk a little bit more about it in a bit, but you'll have more of these shiny photos and each photo will have critical information. So it'll have the date and time on the top left corner. It'll have the moon phase and the temperature on the top right. And I've had people say before, no, we don't know if animals believe in astrology, but we do know that depending on how full of the moon phase, it can actually impact animal behavior, especially our smaller rodents at night. And on the bottom left, we have the camera number, which is the label we use internally to figure out which site goes where. So if we're looking at more images, really clear, crisp, shiny ones, we'll be really lucky and get collared mountain lion moms with her cubs following not far behind. So we've got mama lion front and center with one of her little clever kittens here. And for those with a really good eye, number 2 on this top left corner, hanging out on these mountains. The rocks, it looks like snow. It's just very pale rock in the background. And again, even if you were the most skilled tracker and you have incredible eyesight, you'd be really, really, really lucky, most likely not likely to catch an image like this or just see something out of the blue. You'd have to be stationed there for months on end without breathing, without having a human interference, and all of us being humans kind of makes it tricky. So leaving it to automated cameras to do the trick really makes our lives a lot easier. We'll also get images where you'll catch predator-prey interactions. In this case, we've got a bobcat happily walking around with a rabbit in its mouth. And it's pretty early in the day, and you can still see you've got that neighborhood in the background. And just close by, we have that urban wildlife interface. We're seeing animals doing their thing in what looks like the backyard of a lot of us here. Or you'll catch those really tender moments where, again, just for being a human, we would be really, really lucky to catch it. You'll see this young fawn nursing from her mom here. So just having a camera in the right place at the right time for months on end, hundreds of thousands of photos of grass, and then you get that really shiny, wonderful, jaw-dropping, awe-inspiring image right there. And then one of my favorites here, you have to really squint to see it. It's, again, a little tricky through the digital screen, but we have a gray fox here blending in seamlessly with a lot of this chaparral vegetation taken in November. So it's already nice and dry and crispy, but this fox is doing just fine, working its way through it. And of course, placing the cameras, it's a whole other endeavor on its own. So here, if you're lucky, you will get to a site where initially you placed a post where it was barren, nothing was there. Years later, you have vegetation growing in, and it's awesome and it's great until you're fighting your way through dense vegetation, not really paying too much, giving too much detail to what's going on until you have a ranger with a great sense of humor and decades of experience in the park tell you 5 minutes later, you know you're in a thicket of poison oak, right? So it's a humbling experience, to say the least, when you're going out to deploy and install these cameras. And it's great because you're seeing the wildlife in the park kind of returning, even if it's a little painful to get to the site. Other times, you'll get to an area where the rain and the debris has entirely plummeted your post, where not only is it covered in leaf and branches, you'll find tire debris right next to your post. And if you're really lucky, a tree will have fallen on your once vertical, now horizontal post. So you have to go back and reinstall it. Nature will be nature no matter how much you try planning in advance. Other times you'll get really lucky and see the rain, the wind, the natural everything wash out a post, knock it over, and you're able to find it about 100 meters from where you had initially placed it. Keep in mind, these posts are buried deep in the ground, so it's, again, a humbling experience when you try coordinating things when in the great outdoors with nature doing its own thing. Then we do the very scientific, very professional, highly scientific crawl test, where we place a camera and to make sure it's at an appropriate height, we'll crawl in front of it since most of us are significantly taller, standing upright than a lot of the study species we're looking at. So we want to crawl to make sure we're about chest level so that if the smallest of kangaroo rats to the largest of mule deer walk in front of the camera, they'll still trigger and you're able to get the full range of the animal of the species and properly be able to identify it. It's always, again, humbling experience is the common theme when you're out and about placing these cameras. Other times you'll get to a camera that had been submerged underwater for months because you get unprecedented rains for 2 seasons at a time, and you're there just hacking away at locks for at least an hour just to find the camera covered in debris, but still functional. So that one was pretty cool because we could see the water level rising and it was constantly taking photos. So great experiences in the field overall. And then the cherry on top. This was a site where maybe 10 minutes before we got to the camera, we saw our work glove there and we thought that's kind of funny. And we picked it up and it was still kind of damp. And we thought, oh, strange, but you don't think twice. For us to just look through the photos and see that a pack of coyotes had been munching away and chewing on it. And the cherry on top for this one was that Talisa, the technician photographed on the right-hand side, we're taking photos, we're looking at it, and this clever family, we're assuming, of coyotes, chewed off every finger except for the middle one. And that's when we realized we must have left our glove months ago when we initially deployed the camera. So when we were retrieving it, they were reminding us to practice leave no trace principles and make sure we pick up after ourselves. So in the field, we're getting a lot of great stories. We're getting these firsthand experiences, seeing what's going on. And then when we actually take the time to go through these images in greater detail, it gives you a whole other story. It gives you that rich data we're trying to collect. So this next series of images, we're going to go through comparisons of sites. So looking at the date here on the top left of the header, we can see this is photos of the actual Woolsey Fire. Again, we didn't know it was happening. We just had a camera for a different project at the right place at the right time, and we can see how the fire went through. We would never want to have any person, whether it be a trained firefighter or an avid hiker, out monitoring and seeing how the fire is going through. But these cameras are able to, if it doesn't, the SD card doesn't melt, are able to see how quickly the fire is going through, if it's getting the leaf debris, if it's going from branch to branch, and actually capture the fire in movement. Here we have the same site about 3 years apart, 4 years apart, excuse the typo, from one another. Where on the left, you can see you still have that charred, that dark vegetation. And on the right, after very wet seasons, you have, pretty sure we have some toy on there. We got some chia. We have, I think it's golden yarrow in the front of the image. We're just an explosion of vegetation. We weren't looking for a specific thing. We just want to see how things change over time. And thanks to that vegetation triggering the infrared sensor, we might not have gotten a cute little coyote or a fawn there, but we're able to see how the vegetation has changed in just about 4 years. These two photos were taken exactly 2 years apart. On the left, you can see a rabbit hiding in the corner, just on the bottom right here. And on the right, again, that explosion of vegetation, just from having the camera there. We're not looking for, we're not baiting, we're not trying to trick animals. Come here. We just want to see what's going on and let the camera capture what it'll capture. And then this is the same series of photos I showed earlier from the before and after the Woolsey Fire. From our vegetation team, this is June of 2018 on the left, December of 2018 in the center, and March the following year, 2019 on the right. So we are seeing, this change. Nature is nature. It is doing its thing. It is growing back. It just needs a little bit of time with not another immediate fire coming in and impacting its behavior altogether, but we are seeing this recovery. It's fortunate to an extent. It's pretty passive. We're just taking photos and letting things do what they've got to do. But it's really comforting to see it progressing over time. Not because we're looking for species, not because we're hoping to get a photo. It's just from this long-term monitoring where we're able to go back and reassess over a series of time how things are changing. And with continued long-term monitoring, we're able to process how things will continue to change in case and when another disturbance, whether it be a wildfire, whether it be a change in pattern traffics, how it'll impact a given area. And just want to go over really briefly some preliminary data we have now from the images that we've processed. So on the right, we have an image of one of our many, it's either a desert or cottontail rabbit. I mix up the two very frequently, but for this project, we lump them together because it's pretty difficult to distinguish on camera. And on the left, we have a diagram showing you where all our cameras have been placed for this project. So each point, whether it be a tiny white speck or a large pink circle on the map, shows you where we've placed a camera. And the larger the dot, the brighter the color, the more frequently that camera has collected or taken a photo of that species. So if we're looking overall at this map, we can see that this orange layer, this blob outlined here, is the outline of the Woolsey Fire. And we can see that in both the inside of the fire perimeter as well as outside, we're catching a lot of rabbit detections altogether, which makes sense. There's a lot of rabbits wherever you go. If we were to do the same for a species like the gray fox, we still see foxes both inside and outside of the fire perimeter. There's just significantly less. And it makes sense that there's a good amount of overlap because, like the image on the right shows, foxes do munch away on rabbits, so it's not a surprise that we see an overlap between the species. And because folks always ask for it, some preliminary data on our mountain lions. We don't have very many of them, so it makes sense that we don't have as many detections of them across the park. Now, this doesn't mean that we're going to get photos of all the mountain lions. It just means from our study, from what we've seen in a given range, we're seeing some of these observations altogether. And this is just early data analysis. There's plenty more to come in the near future. And a lot of these images were processed through this platform called Zooniverse. It's a website where anybody who is interested can go online, whether they're at home, at the library, on their phone, on their iPad, on their laptop, can go online, and with the guide we provide you right then and there, help us identify animal species. You don't have to be an expert. You just have to have a little bit of patience to practice going through and getting familiar with identifying a ground squirrel from a fox, from a bobcat. And the guides will kind of walk you through it. I've been trying to upload photos on here for some time, but once I do have images ready to process, I will have them advertised on our social media. But I have several hundreds of thousands of photos that I need help processing, so I could use all the help I can get for those who are interested in practicing their identification skills. And for those who are interested in seeing more of the shiny wow factor photos, I will be hosting the research gallery in the spring in both the Thousand Oaks and Newbury Park libraries. So I was very grateful for SAMO Fund for supporting and funding the project, as well as National Park Service biologists and the interpretation team. We had this gallery on display from August through December of last year, and we want to take the show on the road. So we're hoping to have this exhibit be more of a rotating this gallery taken on a rotating exhibit. So we're finalizing the dates, but if you want to see the images up close in person instead of on a screen, you can head over to the Thousand Oaks and the Newbury Park libraries. And both of these will be posted on our outdoors calendar, which I'll put links for in a little bit once we finalize the details. So I am very much running short on time, so I'm just going to breeze on through this. Some of the takeaway messages I want you to go home and feel good about with learning more about the Woolsey Fire. The Santa Monica Mountains are a highly biodiverse area, and they support a wide variety of wildlife. From bacteria to birds, we support a lot of different species in the area. As part of supporting a lot of different species, we're also part of the Mediterranean ecosystem, that we have vegetation that is fire adapted, not dependent. They'll do okay with the fires, but we don't want too many because it can really do a number on them, especially risking changing ecosystem types, which will diminish these very unique species almost to nothing if we don't have that stability altogether. Long-term monitoring can help observe these changes in the environment and create a baseline for future changes, whether it be with collaring species across the park, whether it be our vegetation team going out and looking at species and areas in a given time period, or having cameras that, when used appropriately, can help us gather valuable data of our wildlife communities. And of course, conservation is only as effective as the collaboration between people and the organization. I am one person. I did not do all of this. I'm relying on a huge network of people, volunteers, team, agencies. And again, I have the great pleasure of chatting with you all, but is by no means all accredited to me. I got to give credit where credit's due, and a lot of it does come from our volunteers, both virtually, who are helping us process images, as well as deploying and retrieving cameras out in the field. So with that, I want to give you all a huge thank you for sticking around with me so late on a Tuesday evening. I have my name, Miroslava Ramos. Thank you again for joining me tonight. I have my contact information there. For those who are interested in learning more about the events hosted through either the Santa Monica Mountains Fund or the National Park Service, check out our calendar at www.samofund.org/calendar. And then I have our social media accounts pinned below. So for those who are interested in volunteering, whether it be coming out and working at our nursery with Antonio Sanchez, who I know is very friendly and wonderful, loves hanging out with CNPS, you can come out and work with our nursery and get some free plants to take home with you. If you want to learn more about gardening and or how to put plants back into the park, you're welcome to do so. And all of these events are volunteer free and are found on our outdoors calendar. So I'm going to stop talking finally so I can address all the comments and I'm sure wonderful questions you have in the chat. But again, thank you all so much for joining me for over an hour talking about photos and images. I'm happy to stick around and answer any questions you might have. Thank you.
Okay, unmuting. Hi. There's a list of questions from the
All
chat.
right.
Do you want to unshare your screen, or are people?
Yeah.
Okay, and then
Yeah, and then I can also copy and paste this information in the chat too. That way everyone can have it and address it as needed.
okay. So there were a couple of questions early on about fire interval, and there are a couple that are kind of integrated. One of the questions was, are there any areas that haven't burned in 70 to 100 years that you can name? I named in the chat Caballero Canyon, which I don't know if it's quite 70 years, but it hasn't burned in a very long time. And your map kind of showed various areas, but old growth chaparral, I guess, is what we're talking about.
Yeah, so that's a great question. And the short answer is there definitely are. We just don't know about them. Because the data that our GIS specialists, who just recently retired after I think 20 plus years in the Park Service, the data that he collected was from 1925 onwards. So there's definitely, I'm sure there are definitely areas that haven't burned in that long. It's just not from data sources that we ourselves have worked with. I just wouldn't be able to say off the top of my head where those sites might have been.
And kind of the same person kind of said, why the wide variety in people giving numbers? Some say 30-year is the fire interval, some say 100. I think you answer that question with your map, and it depends upon the area, but
Yeah.
it's
So
still
Yeah, mean fire intervals, they're going to vary depending on which area you're looking at and the time frame you're looking at. So for example, if we're looking at the eastern portion of the Santa Monica Mountains, the most recent map we had was up to 2023, and that showed it had burned maybe 1 or 2 times. So the mean average interval for that specific area is going to be, closer to the 100-year range. But if you include up to 2025, where the Palisades fire had impacted the area, the number is going to change drastically. And because the Santa Monica Mountains cover such a wide range with a wide range and different agencies, depends on who you ask, what agency they're looking at. If you're looking at areas specific to, Western, Eastern, SEMI, it basically depends. And depending on what specific area you're looking at, it's going to change. But because it's much easier to give a range versus saying SEMI hasn't burned here, and then this part of SEMI hasn't burned here, we give a general number to be safe.
Okay. There was
Sorry, Snowdy, sorry. My question was actually around, like, I've seen different things in the news, especially following the current fires, saying, "Oh, Chaparral is supposed to burn every 30 years, or 15 years is enough, or 60 years or is enough." Like, I just see a wide variety of responses from people on what the appropriate interval is for fires. So I was wondering if you could speak to that.
Yeah. And that's where I hate to say it again, but it always comes down to it depends. So chaparral environments, you'll typically see them along Mediterranean ecosystems, but for us, our ecosystem here is going to be very different to those you'll find in the southern tip of the continent of Africa or southwest of Australia. Because here, our park is between two counties that homes millions of people who come in and out of the park regularly. So we have roads intersecting, meaning we have more human intervention and accidental fires come here and there. So our chaparral environment is going to be very different. And that I'm aware of, it's really hard to make that comparison when these ecosystems are just vary from jurisdiction versus continent versus urbanization altogether. So I'm sorry the answer unfortunately goes back to it depends, but I hope the context provides a little more clarity.
Thank you.
Sure.
There was a couple of comments on controlled burns by indigenous folks. Someone cited that indigenous people historically use controlled burns in our ecosystem. Is there a reason that Santa Monica Mountains doesn't use controlled burns? And then someone said, well, controlled burn in chaparral is not recommended as it leads to type conversion. So you want to comment on that?
Sure. So it is a great question, and it's definitely one a lot of us in the park have frequently, just because, again, we have that strong partnership with our Indigenous partners, and from their practices, just like you mentioned, traditional ecological knowledge shows that controlled burns can help manage and kind of control unprecedented fires from coming in. And from the last conversation I had with our fire crew, it came down to this is a very rough generalization, right? Came down to 3 main principles. One being that for controlled burns, you need to have super specific and like not variable conditions whatsoever. So the temperature, the winds, the precipitation, the humidity has to be just right. Otherwise, you risk the fire no longer having that control. Because our park is in such a heavily urbanized area, that means any urbanization is at a higher risk, even with that controlled burn. And because of that bigger risk, it also means you're going to have a lot more pushback to it. So if, let's say, we have visitors who live right on the edge of Rancho Sierra Vista, if we were to do a controlled burn right there, they, of course, would be much more at risk, not because they're just in proximity to the fire, but because conditions change even just from morning to evening. You have that marine layer in the morning and it gets nice and high and dry a few hours later. In areas that are further inland, like I know Sequoia National Park is a great example. They do a lot of controlled burns. Places with the redwoods where, again, those controlled burns are in areas where fires do very well for the vegetation there. Their controlled burns, they have it, I mean, it's really a science, but even on the best conditions where you have it calculated down to the last 10th decimal point, you can still have controlled burns canceled the morning of because conditions change. Nature will be nature, and we try doing as many calculations as possible. But especially because of how urbanized our area is, we can't risk saying, okay, homeowners, this is what's going to happen. Oh, wait, never mind. Okay, it's happening. Oh, wait, never mind. There's just a lot of, not that there isn't risk without it, but there is a lot of challenges there. And then it does come back to, again, with our chaparral ecosystem, it's it's fire adapted, not fire dependent. And again, if we do have a lot of those burns, and I unfortunately didn't have time to go into too much of it, but with how many invasive grasses and vegetations we have in the area, if we do clear that that top layer of soil, those invasives will just settle in before our other deep-rooted natives can establish themselves first. So long answer is, in an ideal world, yes, but there are just too many unknown variables. Even if we have it really calculated, that would make it too risky to attempt to do a lot of controlled burns in an area that's so highly populated and urbanized.
Okay, another question was, were the state and federal lands in Samo area managed differently, leading to different fire impacts?
Another great question. And again, also will depend. So with state and federal employees, we have seasonal crews of trail folks as well as firefighting teams that will work on fuels abatement. So making sure a certain number of, I think it's feet, if I'm not mistaken, like 200 or so feet, don't quote me on the exact number though, has to be cleared from a certain building distance to make sure if something were to happen, buildings are preserved and kept safe. I want to assume, but I don't have the exact information, that these regulations are standardized across agencies just because we work so closely together with CAL FIRE, State Park, federal firefighters. So if there is a study done on it, I don't know it off the top of my head, but I would assume no, just because of how much collaboration is going on between the agencies.
Yeah, I sense, however, that there may be different agency responses, state versus federal versus MRCA, but I probably know nothing documented that you could put your finger on. There was a comment that the Heritage Creek Preserve at CSU Dominguez Hills has camera traps.
Yes, I wanted to share that. I completed ecology. It was spring of 2022, and I was in the lab. And that semester, we were analyzing data. There were pictures taken from those camera traps. I remember the layout exactly. They might be the exact same ones because I think my professor, he worked at or works with the Santa Monica Mountains. I don't know if he does research there, but he stayed in communication, I suppose. And I just remember like we were analyzing the data. We did an exhaustive lab assignment. We did over the course of several lab periods. Analyzing it was coyotes and there were rabbits. I forget which species right now. The code is SVL. I think their code is SVL. So it's the desert cottontail. Desert cottontail. And there were one or two coyotes, I think a male and a female, in that small creek preserve. It's really small. It's about 1 hectare, and it's about it's in the parking lot 7 of the university campus. So it was just interesting that we were doing that, and he had incorporated it into our ecology laboratory class. So that was neat. I just wanted to share that because the moment I saw the pictures, I was like, oh, that's familiar.
Thank you,
Yeah, I
Tanya.
think with
Right.
camera traps, especially with how there's much more models and they're becoming a lot more accessible. So there's some camera models that charge with solar, some that connect with cell cameras, or even just ring cameras. It's getting a lot more accessible to non-researchers. So again, if you want to put one on your own property and find out what you get, that's, I mean, that's exciting too. It's still considered research. So it's exciting to see that there's a lot of photos and a lot of work going on it. The Park Service is definitely not the only agency who uses camera traps. It's just the versatility of them, I think, makes it such a great learning tool. It makes it a great interpretation tool to show you what's going on in the park. But yeah, of course, it works for research tool, but I'm always a sucker going through the photos and saying, wow, it's a deer and you can see its whole face and not just its butt. So it's good all around.
Okay, selfishly, I have 3 questions that I wrote down.
Yeah, let's go,
Okay,
Snowdy.
so here's how do you said there were millions of images. Now, is there software of some sort that says, here's an image that actually has something for a human to actually look at? How do you call out the DREC to come up with the fact that maybe there's only an ear of a jackrabbit, but it's an animal there?
Yeah, so I cheat. I I have for this project, we have a volunteer. His name's Dan Morris, and he developed this AI program software, computer talk, where it goes through images and it I'm sure it's not, but I believe it's magic, where it goes through and identifies images just as that. So it'll look for if it's vegetation or if it's just wind, but because it goes through the photos, it also has the timestamp. So if there's like maybe a tip of an ear at 22 minutes and 4 seconds, and then at 22 minutes, 4 seconds, and 4 milliseconds, there's another bit that could also be tagged as an ear. There are other platforms that our park is looking into as far as getting a handle and kind of teaching a computer how to process it for us. But I don't think we're at the point where we can say, here, computer, tell me how many images of coyote there are. It can tell you animal, but just, I know for me, I wouldn't feel comfortable saying these are all coyote. I'd want either a me or a person to go through and process it. But I know even just in undergrad a handful of years ago, one of my internship was just spending hours and hours and hours going through photos manually. So there are programs that are getting better at processing. I don't know, we're not for sure for this project. I know there's, I'm sure, other projects across the world that are getting to the point where they're able to have a program identified to species. I'm sure we're on that path in the grand scheme of things. But just to answer your question, I don't do it personally. A very kind volunteer helps out with it, but there are programs that'll comb through the blanks versus the animal photos.
Okay, great. Do you have GPS on those cameras? Because like when one is washed down the river, or did you just happen to luck out and here it is? Or does the camera have GPS? So you can actually find it.
I've made jokes where in an ideal world I'd have air tags on the cameras or something with it. But for most of these sites, they're intentionally off trail. So it's in an area that's not going to have great cell coverage, even in such an urbanized area. So the cameras themselves, the ones that I use, don't have GPS units, but because we are rotating the cameras on a consistent basis, the post isn't going to move anytime soon. So we have the coordinate of the post. So we'll bounce back and forth there. Now, if something happens to the post, then it is like a game of I Spy and a scavenger hunt for it, which is why the photos I showed where you can actually find the post were both good and bad, because bad, it went out, but good, because hey, you found it. But there are sites where, if the camera, you place the camera there, you took notes that camera 1 was placed at site 2 and the camera's gone. That's where we check our notes. Was it deployed properly, or is it a chance that the camera was stolen? Did it melt off? Did something happen to it? So it's a lot of learning by error. And I've been very grateful to kind of adopt the project from the grad student, Chloe, who put this up and running together. And of course, the park and its partners are very formidable. It's wonderful working with a place where you can openly ask a stupid question and get a snarky remark back, but the answer with a smile afterwards.
You had you had several preliminary data maps. That's a lot of data for rabbits and fox and cats, right?
Right.
Who's doing that data entry? How is that data captured and put into a map format? Is that also just grunt work by a human?
Yes and no. So Chloe Neziel, this was her master's thesis project, her master's work when she helped establish the program when she was still with UCLA. And a lot of her work, I want to say at least a year or so, was just data analysis. So she would be using RStudio, she would be using Python, a lot of coding to get images to numbers and then modeling to figure out who goes where. And I say this is preliminary just because she graduated in 2021, 1, around there, and it's still being processed right now. Not because, she's on vacation for 3 years, but there's just so much data to go through, and there's a lot of fine tuning to do. So what's really great about this project is that it doesn't matter how many staff, how many researchers, how many grad students are working on this project, the data is always going to be there. So when new technologies, new models, new iterations to understand and interpret the data come, we can reprocess that data and say, okay, version 1 was pretty good, version 2 is great, version 3 we're comfortable for, but the versions will constantly keep coming as technology keeps advancing.
Well, you had mentioned Zooniverse, and how do people get involved with that? Is there some link on the SAMO website, or how would someone use? I think you mentioned that volunteers can ID animals for the project.
Yeah. So Zooniverse is a web-based platform where folks can reach out to citizen or community scientists, in this case, volunteers who help out with the research project. And it could be from identifying animals. I've seen some projects where folks will put photos from Antarctica and you help count penguins, some who help type up older manuscripts that are in like fancy script and cursive and all of that. So for this project, it is online on Zooniverse. It's just, if you were to go to our website, I think the project's called Wildlife of Los Angeles or Wildlife of LA. There's nothing to process because we haven't uploaded any photos there to go through. So I guess still got to put it in the chat, but I would encourage folks who are interested in helping out with this project. I would recommend, not because I get like a commission or anything, if you follow us on social media, what I'll end up doing is once photos are ready to be processed, I'll have our social media team, I'll ask them, hey, can you put out a social media post announcing to the world, I need volunteers to process 200,000 photos for me. So nothing is set in stone yet. But if you want to practice, we do have some photos there that have already been processed. You can just get get a feel for the guide, click through the website. And I will say it's much easier on a computer with a bigger screen than a phone. You could do it either way, but I prefer a desktop or larger screen, just so you can really see the image in its clarity.
Okay, great. Somebody asked for a comment on the effects of that red fire retardant.
So with the FOSS check, we had a meeting about it not too long ago, especially when it came in regards to the Palisades fire. And we know from what the fire ecologists mentioned to us that the FOSS check, I don't know if that's the commercial name or the casual name given to it. It's basically an overload of nutrients to help dampen down and reduce the fire spreading to a certain area. So it looks almost comical. It's just pink splotches on at times very vibrant green vegetation. And I don't, off the top of my head, I wouldn't be able to tell you the impacts it has specifically on vegetation or on soil. But I do know the fire ecologist mentioned that it does wash away pretty readily with rain. But there have been studies confirming that the phosphates can be detrimental to aquatic wildlife. So if there's a stream nearby and phosphates is there, it can really do a number on those populations. And for our park, we're constantly worried about our red-legged frogs. I want to say they're not endangered. I think they're threatened. I can't tell I remember if it's on a state or a federal level. But there's always we have specialists working with our fire team saying, hey, avoid placing, this phosphates in certain areas. But again, when it comes to our firefighting properties, it's focusing on lives first, then properties, then resources. So we can try working with them as best as possible. But in that high stress situation, when you see a fire coming in, they're going to do their best to prevent that fire from spreading. And it's very bittersweet because you want to be there to be like, hey, let's minimize this impact. But at the same time, you want to acknowledge that the firefighters are there to do their jobs and prioritize saving lives. So phosphates does have an impact on aquatic lives. I don't know off the top of my head off of vegetation, but our fire ecologists have said that the phosphates does wash away easily with rains when they come.
Thank you. Is there any data that you know of on recovery of Quercus agrifolia? Um, uh, Data on tree mortality from the Woolsey Fire?
They're a great question. I don't have it off the top of my head, but I do know the vegetation inventory and monitoring team of our park and its network. So we collaborate with the Channel Islands as well as the Cabrillo National Monument over in San Diego. I know I want to say they have a paper or a report coming out relatively soon. And if not, I'll see if I can put their website in the chat. They have some great resources there, but off the top of my head, I wouldn't be able to tell you.
Okay, thank you. Do you have or do you know of any preliminary data on the impacts of the Palisades fire? And I'm assuming that's to ecological impacts because I think we kind of know the numbers on human impacts.
Right. It's definitely too soon to tell with the Palisades. And I think because we know the number of homes, the number of, the cars, the leaching of all these chemicals are in the environment, it'll probably be a while before we can really understand, one, get testing and see how it changes over time, especially with the rains we've been having and the next storm coming by pretty soon. And it'll be a while, but I know that's one of the big things our researchers are really concerned about. For us, with this project specifically, I had 5 cameras that were in the burn scar and 2 of them melted. One of them, we were able to see the fire going through, similar to how we accidentally caught photos of the Woolsey Fire when it came in. And the other one entirely melted. So the SD card was just dust. So it's too soon to say for that one. It'll be some time because even right now, they don't want too many folks out there because of how much other stuff is in the air. But there's at least, we're not the only agency who's going to be out there working. I know, I forget the one that does testing on water and air quality. They're probably going to be out there right away too, making sure it's safe to kind of clear out debris and establish when it's safe for folks to rebuild if they're interested in doing so.
Getting back to the Quercus, Mark Mendelson mentioned that Rosie Daga has the RCD has data.
Hi, Mark.
And I think the last, well, it's a comment, not a question in the chat. Well, here's actually a question. Did you talk about seawater use on fire reduction during that same FOSS check meeting? in
We
regards
did-
to change on vegetation?
We did not when it came to seawater use. I'm sure, again, it will have an impact. It's just, I wouldn't be able to say personally what it's going to be. And I think it'll take some time just seeing how the vegetation kind of responds to it to really understand the grasp of it. Because even now, 7 years after the Woolsey Fire, we're still trying to understand and comb through the intricacies of the fire there. So it's one of the beautiful things where nature will kind of like shake itself off and continue going on, but we're still trying to understand where that line is. Is it still recovering? Is it catching its breath? But with these long-term monitoring studies, we're hoping to get a better idea. But yeah, no talk about seawater use for the Palisades fire.
In the other comment, somebody did mention the Fowler Museum at UCLA has a current exhibition going on fire kinship. And apparently it's an art and science focused exhibition on indigenous folks and fire. So if you haven't been to the Fowler lately, you could go over there. Admission to the Fowler is free, but you know, at UCLA you pay, I don't know, $14, $15 to park. So I'm seeing if this is a question. People are just saying thank you at this point. And Miroslava just put her contact information in the chat.
Forgot to do it earlier. So if you're still there, thank you.
Is there anybody who wants to ask a question in person before we close? And did I skip a question? You know, sometimes I zone out, but well, this has been fascinating. I think we all learned so much. And you know, those few images you showed were kind of a teaser, I think, where people were going, "Oh no, he's got a rabbit in his mouth." I'm sure that those are the highlights when you catch something like that. Just it's makes your research life worthwhile. Somebody is asking a final question. What about remote sensing? I'm not sure what that means, Mark. Remote sensing of what? Remote sensing. That's Mark Osako. I don't know the context of the question, so.
I know we have in terms of like GIS satellite data, I know we collect for our maps, we use pretty we can kind of go back in time depending on when satellite imagery is available. So we can, depending on the time frame, see like plumes of smoke in an area. But I'm not sure. Oh, I'm thinking mainly of satellite sensing vegetation, but there are other methods as well. For vegetation, I would not be able to say off the top of my head if NPS does it specifically. I think MRCA year or so ago, maybe 2 years ago now, they had some sort of similar training for it. But again, I wouldn't be able to say. I wouldn't be surprised. I'm not aware of it if it's there.
Actually, I can kind of speak to that, and she's retired, but Marty Witter used to do huge amounts of remote sensing of fire, post-fire vegetation mapping. But I don't, maybe, I don't know if Mark Mendelson is still, he looks like he's still logged on. He may know if Marty's work has been continued, but
Yeah, hi Snowdy and Miro. I can speak to that if you'd like.
yeah, please.
Sure, yeah. So I kind of took over some of the projects that Marty Witter started. And we have done remote sensing of our vegetation, Mark, mostly through partners. We had a pretty cool project that Althouse and Mead, a consulting firm out of Paso Robles. They used drone flight imagery that over our vegetation monitoring plots, actually. And then they tried to correlate those data to satellite imagery. They were mostly able to not go down to species, but mostly just whether it was woody vegetation or not. And then we've worked with other partners who are using hyperspectral imagery from fixed wing aircraft flown over the park and Channel Islands and Angeles National Forest. That was based out of Arizona State University and University of Arizona with a CSUN grad student. And we got really interesting data from that, and from those data, they could actually go down to species level because they also went out into the field and they ground truthed some of those images with actual species on the ground. Thirdly, we had helicopter flown imagery taken by wildland conservation science, and they took tremendously detailed photos of mostly mapping our weeds around the park. And we just kind of got those data, and Miro and my coworker, Joey Algiers, he has those data, and we're kind of still looking at them and processing them. But one major finding from the helicopter flights were just the crazy abundance of Cape ivy and euphorbia and arundo that we really, we kind of knew about, but now we have it really well mapped. So yeah, some exciting remote sensing data happening. Thanks for asking. I hope that helped.
Yeah, it certainly did. Thanks so much. Maybe that's another program in the future. Okay. All right. Anybody else who has a question? Otherwise, we will shut it down. Look forward to maybe people volunteering to help out with this effort too. And we'll try to get the word out, Thank you so much. It's a wonderful project, very worthy.
Yeah, hope
thank you,
to see some of
Miroslava.
you in person in the libraries once the exhibit's up and ready in the spring. Looking forward
Yeah.
to it.
I saw the one, that was at King Gillette Ranch. Is that going to be kind of the similar one or? Okay.
Yeah.
All right. We'll try to get the word on that too. All right, guys. Thanks for your attention and your great questions. Miroslava, so much thank you for your very, wonderful presentation. And we appreciate all you do. Take care. I'll end the program. Take care, guys. Good evening. Bye-bye.
Good night.